Okay, good morning, all of you. In last lecture, we have started unit number 7, shear stresses in beam. And we have already discussed some theoretical points in that unit. So already we have discussed yesterday, whenever we will apply load, at that time, two types of stresses will be generated in that beam. Which two types of stresses will be generated? First one is the shear stress and second one is the bending. Okay, so after that we have discussed how to find out shear stress. Okay, so shear stress is denoted by using tau, and the equation for finding out shear stresses in beam is SA y bar divided by IB. Here S nothing but shear force. A y bar means area into y bar, that is centroid of that particular axis from neutral axis. After that, I is already that moment of inertia, and this B is nothing but width. But this width will change according to location. After that, we have discussed how find out shear force in rectangular section. Okay, so tau max, which is equal to 3 by 2 tau average, and tau average means tau average is nothing but force divided by area. S means shear force and area is B into D. After that, we have discussed for circular section. So for circular section, maximum shear stress, which is equal to 4 by 3 into tau average. Okay. After that, we have solved numericals. Okay. In previous lecture, we have solved numericals on rectangular section as well as symmetric eye section. So today we will continue numericals on unsymmetric sections. Please write down next example. A cast iron bracket, a cast iron bracket, cast iron bracket, cast iron bracket has a cross section of I shape, has a cross section of I shape, cross section of I shape as shown in figure. I shape as shown in figure. As shown in figure below. As shown in figure below. Full stop. The section is subjected to. The section is subjected to. Section is subjected to a shear force of, subjected to a shear force of 1600 kilonewton. 1600 kilonewton. Full stop. Draw the shear stress distribution over the section. Draw the shear stress distribution shear stress distribution over the section. Over the section. So here I section is given, and in that question directly the value of shear force is given. First I will draw here I section, simultaneously you can also draw, then we will solve. This is 300 mm. After that, this one is a 50 mm. that this depth is 300 mm. This width is also 50 mm. And this is 200 mm. 200 mm. So this section is given. So by observing this figure, this section is unsymmetric section. Okay, first we will write which parameters are given, then we will solve. So shear force, that is the value of S is given, S which is equal to 1600 kilonewton. After that, the dimensions of this I section is given. So first you require moment of inertia. First you require moment of inertia. And this section is unsymmetric section. So how you will find out the moment of inertia for this? By preparing table. 50 mm, 50 mm, I will write here. So in table, first is the section. After that, area. After area, next parameter is yi, that is y bar for that particular section from base. After that, ai, yi. Second last is ai, yi square. And last one is the moment of inertia. First section, after that area, that is ai, after that yi, next is ai, yi, next is ai, yi square, and last one is the I square. Okay, so whenever we will prepare this table, at that time you have to remember we are finding out by considering this as a baseline. So we will consider this as a section 1. So this is suppose section 1, this is 2, and this is section 3. So first we will write for section 1. So for section 1, width is 200 mm and depth is 50 mm. So 200 into 50, which is equal to how much? 10,000. Okay. After that, we have to mark y bar. So y bar we are considering from this 1 axis. Okay. So half of this 50. So 50 by 2, which is equal to how much? 25. After that, next parameter is ai, yi. So you multiply this and give the answer how much? So 50 into 10 to the power 3. After that, ai, yi square. That means 25 square into area. 6.25 into 10 to the power 6. After that, we have to find out the moment of inertia for that particular section. And this particular section is rectangular section. So, moment of inertia for rectangular section is BD cube by 12. And this B and D is depend on about which axis we are going to find out moment of inertia. So, we are going to find out about x-axis. So the length parallel to that axis we will consider as a B, and length perpendicular to that axis we will consider as a D. So according to this, 200 is width and 50 is depth. So 200 into 50 cube divided by 12. So it is equal to 2.083 into 10 raised to 6. So section 1 is completed. Then we will move towards section 2. Okay, so this is the section. Okay, you observe this is our section 2nd. So for section 2nd, we will write area. This is the width and this much, that much is the depth. So 50 into 300, which is equal to 15,000. After that, y bar. We are calculating from this base. So first we have to take this 50. So 50 plus 300 by 2. So 200. Okay. After that, AIYI. 3 into 10 raised to 6. After that, AIYI square. 600 into 10 raised to 6. And last one is the BD cube upon 12. Here also, this is rectangular section. So, moment of inertia for that particular section is width is 50 into depth is 300. Depth is 300 cube divided by 12. So, you calculate and tell me how much? 112.5 into 10 raised to 6. So now section 2nd is over. We will move towards section 3rd. So this is our section 3rd. Area for section 3rd is 300 into 50. So 15,000. After that, y bar. From this base, 50 plus 300, that is 350 plus 50 by 2, which is equal to 375. After that, AIYI 5.625 into 10 raised to 6. After that, AIYI square 2.109 into 10 to the power 9. After that, we will calculate moment of inertia by using BD cube upon 12. So width is 300 into depth is 50 cube divided by 12, which is equal to how much? Okay, 3.125 into 10 to the power 6. Now calculations are over. So we will take addition, summation of. So first summation of area, which is equal to how much? Yes, summation of area 40,000. Summation of area 40,000. Okay. YI is not required. After that, AIYI 538. 8 point something with us. Yes, how much?
8.62.75 into 10 raised to 6.
8 point.
No, 862.75.
I will write 8.875 into 10 raised to 6. After that, AIYI square 2.10 raised to 9. Okay, 2.706 into 10 raised to 9. and after that summation of I self, which is equal to 117.70 into 10 raised to 6. Okay. After that, next parameter you have to find out, that is y bar. How we will calculate y bar? Y bar, which is equal to summation of ai yi divided by summation of ai. So y bar, which is equal to summation of ai yi is 8.875 into 10 raised to 6 divided by summation of ai is 40,000. So calculate and tell me y bar, which is equal to how much? 200. Okay, point
75.
875 mm. एवढ्या दिवसात पहिल्यांदा आधी y bar, which is equal to 221.875 mm. Then we will calculate y max. Okay, so you observe here from bottom. Okay, from bottom, depth of neutral axis is 221.875. So from top, remaining distance is how much? Okay, this is 300 plus 50 plus 50. 400 minus 221.1.30. Huh. 178.125. Okay. So above neutral axis depth is 178.125 and below neutral axis depth is 221.175. Okay. So y max is 221.875 mm. After that, next we have to calculate moment of inertia about base. So we will find here I11. Next is I11. So what is the equation? I11, which is equal to summation of I self plus summation of ai yi square. So I11, which is equal to summation of I self is 117.7 into 10 raised to 6 plus AIYI square is 2.706 into 10 raised to 9. So accordingly you calculate and tell me I11, which is equal to how much?
2.81 into 9.
2.80 into
10 raised to 9.
okay, 2.81 into 10 raised to 9 mm raised to 4. After that, we have to calculate moment of inertia about this x-axis. So I11, which is equal to Ixx plus summation of ai into y bar square. So I11 already we have calculated 2.81 into 10 raised to 9, which is equal to Ixx we will write as it is plus summation of ai is 40,000 and y bar already we have calculated 221.875 square. So we will shift these two terms to left side. So 2.81 into 10 raised to 9 minus 40,000 into 221.875 square, which is equal to Ixx. So you calculate and tell me Ixx, which is equal to how much?
196 10 raised to 9.
नाही चुकते काहीतरी आदित्य. रिपीट करा हा बरोबर आहे 0 8 बर 860 860 येत आहे का 863 येत आहे चेक करा जरा प्रत्येकाचा आन्सर वेगळाच होतो काय तुमचं मला प्रॉब्लेम असतो हा जे ऑनलाईन अटेंड करतात सांगा आन्सर किती येते गणेश
हा 1.96 into 10 raised to 9.
चुकते काय तर चेक करा हा
Now, Shida, if you take it to 67.
नाही हो
840 मॅडम.
नाही 840 तर नाहीच येते चेक करा
But the data is
855.03 into 10 raised to 6.
863 च्या नियर अबाउट आन्सर आलं पाहिजे बघा.
841 into 10 raised to 6.
किती येत आहे हा श्रुती
841 into 10 raised to 6.
नाही आन्सर व्हॅरी व्हायची काहीच गरज नाही याला बरं कॅल्क्युलेटर तुमचं काय आन्सर चुकते मला हेच कळत नाही
850 into 10 raised to 6.
एट 40.85 into 10 raised to 6 मॅडम.
860 पुन्हा चालते 860 बघा चेक करा नियर अबाउट 863 यायला पाहिजे 860 येत आहे तुमचं 860 पॉइंट किती आलं पॉइंट ओके 860 into 10 raised to 6 mm raised to 4 okay so this is the movement of inertia okay after that we have to calculate here concentrate here I11 2.8 23 ओके बर इथे हे घेऊन बघा मग येते का चेक करा 2.8 2.832 okay 2.8329 into 10 raised to 9 mm raised to 4 आणि आता चेक करा बरं चेक हे डिजिट थोडे कमी जास्त झाले ना त्यामुळे आन्सर चुकतंय तुमचं so here 2.8329 into
मॅडम 863.75
75.
Okay,
865.75 into 10 raised to 6.
okay 863 ना 863.75 into 10 raised to 6 mm raised to 4 okay so this is the movement of inertia please concentrate here now once you got movement of inertia next target is you have to find out the shear stresses at important locations so first we will mark points here so suppose this is a point here B here C point here D point here E F and last one is the G now you tell me in previous problems we have solved suppose shear stress at B which is equal to shear stress at F now that condition is possible here or not No, because of this section is unsymmetric. So we have to find out shear stresses at each and every point. So shear stress at A and G, which is equal to how much? 0, because of at top and bottom shear stress is always 0. So we will start in next slide. First I will draw here I section. So you will able to take dimensions. बोला आकाश. Y बार घ्यायचा Y बार. मॅक्सिमम ते स्ट्रेसेस कॅल्क्युलेशन साठी लागते. मॅक्सिमम ज्यावेळी तुम्हाला आता बघा तुमचा इथे डाऊट थोडं कन्फ्युजन होतंय तुमचं की इथे आपण ज्यावेळी IXX फाइंड आउट करतोय त्यावेळी Y बार स्क्वेअर इथे तुम्हाला वाटते की Y मॅक्स. तर हा Y मॅक्स कशासाठी लागतोय की आपल्याला जेव्हा स्ट्रेसेस फाइंड आउट करायचे स्ट्रेस फाइंड आउट करताना ज्यावेळी आपण मॅक्सिमम स्ट्रेस फाइंड आउट करणार आहे त्याच वेळी फक्त Y मॅक्स यूज करायचा आहे. अदरवाईज ज्यावेळी आपण मोमेंट ऑफ इनर्शिया कॅल्क्युलेट करतोय त्यावेळी Y बार जो आपल्या ह्या स्टेपनी येतोय तोच यूज करायचा आहे. फक्त हा Y मॅक्स यूज कशासाठी आहे फॉर फाइंडिंग आउट द मॅक्सिमम स्ट्रेसेस. At that time you have to use this Y max. Otherwise you have to use this Y bar for calculating moment of inertia. Okay, so tell me dimensions. This dimension is 300 mm. This dimension is 50. After that, this is also 50. This is 200 and this is 50. Distance from bottom. 2875 and distance from top
178.125.
178.125. So this is our I section. Here A point, this is B, C, D, E, F and G. So shear stress at A, which is equal to shear stress at G, which is equal to 0. After that, we will calculate shear stress at B. So now you tell me tau B, which is equal to, equation is SA Y bar divided by IB. So tau B, which is equal to S, shear force is given 1600 in kilonewton, but other parameters are in mm, so we will convert into Newton. So 10 raised to 3 into AY bar. We are calculating at this B point. So that means this whole strip will comes under this B point. So area is 300 into 50 into Y bar. Now from this neutral axis to centroid of this strip is nothing but Y bar. So 178.125. I will write here 178.125 minus 50 divided by 2. Then you calculate tau B, which is equal to how much? How much? 1? Yes. Wait. We will write about this. So not confusion will be there. So here Y bar is 178.125 minus 50 by 2 and divided by moment of inertia 863.75 into 10 raised to 6 into, now you tell me width which is equal to how much? This total 300. So into 300. Now calculate and tell me how much? Yes.
14.18.
Yes, 14.18 Newton per mm square. So that much stress will be generated at B point. After that, we will calculate shear stress at C. Okay, shear stress at C. So tau C, which is equal to same equation SA y bar divided by IB. Here all values are same, only this width will be changed. So tau C, which is equal to shear force is 1600 into 10 raised to 3 into area. Here also this strip will become, so 300 into 50. Y bar is again same, 178.125 minus 50 by 2. Only width will be changed, and width is how much? 50. 863.75 into 10 raised to 6 into width is 50. So accordingly you calculate and tell me tau C, which is equal to how much? Eighty.
5.09.
85.09.
Okay, 85.09 Newton per mm square. So that much stress will be generated at C point. After that, next we will calculate at D. So shear stress at D is nothing but shear stress at which axis? Neutral axis. So next point is shear stress at D, that is tau D, which is equal to, equation is same, SA y bar divided by IB. So tau D, which is equal to shear force is 1600 into 10 raised to 6, sorry, 10 raised to 3, 10 raised to 3 into, now we are finding out this D point. So above this D point, we have to consider area. So here two strips will be there. This is first and this is second. For first strip, we will write this as it is, and for second strip we have to calculate. For first strip, area is nothing but 300 into 50 into this centroid is 178.125 minus 50 by 2. Okay, plus now we will consider this second strip. Width of the second strip is 50. Okay, 50 into this height. Okay, this total depth is 300. Okay, this total depth is 300. So out of that how much remaining? 150. Okay, we are calculating at E. But this is not symmetric section. No? Symmetric section असेल तरच आपण 300/2 करून 150 घेऊ शकतो. हा अनसिमेट्रिक सेक्शन आहे, मग कसं काढणार कोण सांगतं? किती लो डेप्थ? बघा एक लक्षात घ्या, न्यूट्रल ऍक्सिस पासून टॉप पर्यंत किती डेप्थ आहे? 178 आहे. त्याच्यातून जर आपण हे 50 मायनस केले तर हे डिस्टन्स मिळतंय. मग ते किती असणार आहे? 50 into 128 point how much? 125. Okay, 125 into centroid of this, म्हणजे आपलं हे डिस्टन्स किती आलेलं आहे? 128.125 डिवायडेड बाय 2, म्हणजे त्या पर्टिक्युलर सेक्शनचा CG असेल. So 128.125 divided by 2. So this is the area for this B section. Then you have to divide by moment of inertia and width. So moment of inertia is 863.75 into 10 raised to 6 into width. Width at D is 50. So calculate and tell me tau D, which is equal to how much?
And
83.42.
गणेश चुकतंय तुमचं काय तर चेक करा. हा
100.29.
ओके, 100.29 न्यूटन पर mm square. 100.29 न्यूटन पर mm square. जर तुमची एक्झाम ऑफलाईन झाली तर तुमचं अवघड आहे बरं का, तुम्हाला कॅल्क्युलेशनच जमत नाही, कॅल्क्युलेटरच यूज करता येत नाही. आज कसं होणार आहे तुम्ही मग? प्रॅक्टिस करा जरा थोडी. फक्त ब्रॅकेट व्यवस्थित टाकले ना तुम्हाला आन्सर मिळते. ब्रॅकेट फक्त टाकायचे आणि क्लोज करायचे जमले तर आन्सर व्यवस्थित येतो, नाहीतर मग तुमच्या स्टेप्सला मार्क्स मिळतील पण फायनल आन्सर चुकलं तर तुम्हाला फुल मार्क्स मिळणार नाही बरं का. ते कसं एक्झाम होती त्याच्यावर डिपेंड आहे, पण तुम्हाला कॅल्क्युलेटर यूज करता आलं पाहिजे. आफ्टर दॅट फर्स्ट वी विल कॅल्क्युलेट फॉर एफ अँड देन वी विल कॅल्क्युलेट फॉर ई. ओके, सो नेक्स्ट shear stress at F. First we will calculate for F. So tau F, which is equal to same equation SA y bar divided by IB. So S, shear stress 1600 into 10 raised to 3 into, now we are calculating at F. Okay, please concentrate here. We are calculating at F, that means area below this F. Okay, so here this strip will be come under this F point. So area is 200 into 50. Okay, into y bar. So y bar is from this neutral axis to centroid distance. So y bar is 221.875 minus 50 by 2. This is A y bar divided by moment of inertia 863.75 into 10 raised to 6 into, now you tell me width, which is equal to how much? 200. Okay, so 200. So tau F, which is equal to how much? Yes, 18.23 Newton per mm square. And last is remaining, that is shear stress at which point? Shear stress at E. Sorry, EE, right? E. Last we will calculate shear stress at E. So tau E, which is equal to SA y bar divided by IB, which is equal to shear force is 1600 into 10 raised to 3 into area is same 200 into 50. Again y bar is same, only here width will be changed. So y bar is 221.875 minus 50 by 2, then divided by moment of inertia 863.75 into 10 raised to 6 into width is how much for this E point? 50. So tau E, which is equal to how much?
72.93.
Okay, 72.93
3.
Newton per mm square. So if unsymmetric section is given, at that time you have to find out stresses at each and every point. After that we will draw stress distribution diagram here. So first I will draw original figure, then we will draw stress distribution diagram. विजय काय आहे बाहेर? Okay, first we will mark points and then we will draw. This is A point, B, C. This is T. This point is E. This is F. And last one is the G. This distance is 300. This is also 300. This is 50 and this is also 50. This is 200. So shear stress at A, 0. Shear stress at G, 0. After that, shear stress at B. Shear stress at B, 14.18. After that, shear stress at C, 85.09. After that, shear force at D, 100.29. After that, shear force at F, 18.23. And shear force, no. First, we have to locate E point. So shear force at E, 70. E काढलाय की आपण
72.98.
72.98. So 85 च्या आधी मार्क करावं लागेल आपल्याला. F 18.23 आणि E किती आपला 72.98. पहिले आपण F फाइंड आउट केलाय कारण तुम्हाला हे विड्थ लक्षात येण्यासाठी. सो F ला किती आहे 72 म्हणजे या 85 च्या आधी ड्रॉ केला पाहिजे आपण इथे कुठे 72.93 and shear force at F 18.23 म्हणजे ह्या 14 च्या पुढे असला पाहिजे तो. Suppose here 18.23. After that, connection from A to B is parabolic. From B to C is straight line. From C to D and D to E, parabolic. E to F, straight line. And F to, this is parabolic. So this is the shear stress distribution diagram. If unsymmetric section is given at that time, you have to solve this question likewise. After that, we will solve like next example for T section, and then we will take another example for the psi section. So please take screenshots. Those students are attending online, please take screenshots. So we will solve example on T section. Same procedure for T section. Instead of these 3 sections, only 2 parts will be there. That much change. Okay, please write down next example. Draw the shear stress distribution diagram. Sorry. Draw the shear stress distribution diagram. काय कशाचा उपयोग म्हणताय हे जे काढतोय हे आता बघा तुमचा शिअर स्ट्रेस इन प्रॅक्टिकल शिअर स्ट्रेस कुठे येतो तुमचा सपोर्टला येतो तर ह्या डिस्ट्रीब्युशन वरून आपल्याला लक्षात येतं की कुठल्या पॉइंटला किती स्ट्रेस ऍक्ट होणार आहे आणि त्या पॉइंटला किती स्टील प्रोव्हाइड केलं पाहिजे त्याच्यासाठी आपण हे फाइंड आउट करतो तर इथे काय ते सपोज वी आर प्रोव्हाइडिंग आय सेक्शन then at top and bottom there will be zero stress so minimum still sufficient but shear stress at depth of neutral axis is maximum so here still reinforcement is maximum so for this we are calculating okay shear stress distribution diagram for the T section, shear stress distribution diagram for the T section, shown in the figure below. T section shown in figure below. Shown in figure below. Full stop. Take shear force which is equal to 100 kilonewton. Take shear force is 1000 kilonewton. 1000 kilonewton. So this is the question. I will draw here figure. The T section is given. So the width of flange is 300 mm. Depth of flange is 50 mm. 50 mm. After that, width of wave is 50 mm and the depth of this wave is 200 mm. We'll mark points here. Suppose this is A, B. After that, this is C. Wherever neutral axis will come, this as a D, and last one is the E. So, from starting, first we have to find out moment of inertia by applying table. So, in table, first parameter is section. After that, second is AI. After that, next one is AIYI. Sorry, YI. Next one is YI. After that, next is AIYI. AIYI square. Time being, you start for solving. Okay, I will write here all parameters first. So section, after that AI, next is YI, next one is AIYI, next is AIYI square, and last one is the I cell. So first we will consider this as a section 1 and this as a section 2. So section 1, area for section 1 is 200 into 50. 50 into 200. How much? 10,000. After that, YI 200 by 2. That is 100 mm. 200 by 2, which is equal to 100. After that, AIYI 1 into 10 to the power 6. AIYI square 100 into 10 to the power 6. And then I cell B is 50 into 200 cube divided by 12, which is equal to 33.33 into 10 to the power 6. So calculations for section 1 is over. After that, we will calculate for section 2. Okay. So section 2, area for section 2 is how much? 300 into 50. So 15,000. After that, YI is 200 plus 50 by 2, which is equal to 225. After that, AIYI 3.375 into 10 to the power 6. After that, AIYI square 759.375 into 10 to the power 6, and I self is 300 into depth is 50 cube divided by 12, which is equal to 125 into 10 to the power 6. After that, next we will take summation. Yes, summation of AI, which is equal to 25,000. No? Okay, this YI is not required. AIYI 4.375 into 10 raised to 6. AIYI square 8,375 into, and some I self, summation of I self 36.45 into 10 to the power 6. After that, next you have to calculate Y bar. So Y bar is nothing but summation AIYI divided by summation AI. So which is equal to summation AIYI is 4.375 into 10 to the power 6 divided by summation of AI is 25,000. How much? 175 mm from bottom. Okay, so this distance is 175. Now you calculate top distance from this to this. Total is 200 plus 50, that is 250 minus 175. How much? 75 mm. Okay, 75 mm. So this is the y bar, and y max is nothing but 175. Not required here, but we will write here 175. After that, we will calculate AI, YI. Sorry, I11. So I11, which is equal to summation of I self plus summation of AI, YI square. So I11, which is equal to summation of I self is 36.45 into 10 to the power 6 plus summation of AIYI square is 859.375 into 10 to the power 6. So I11, which is equal to
895.82 into 10 raised to 6.
895.82 into 10 to the power 6 mm raised to 4. After that, we will calculate Ixx. So I11, which is equal to Ixx plus summation of AI into y bar square. So I11 is 895.82 into 10 to the power 6, which is equal to Ixx plus summation of area is 25,000 into y bar is 175 square. So accordingly, you calculate and tell me Ixx, which is equal to how much?
One 30.95 into 10 raised
One
to 30.195 into 10 raised to 6.
130.
0.
Okay, 130.2.
195 into 10 raised to 6. 0.195.
130.
0.2055.
Okay, right. Correct answer. 205 into 10 raised to 6 mm raised to 4. So this is the movement of inertia. After that, next we have to calculate stress distributions. Okay, so we will calculate here. So stress at A and E, which is equal to how much? Stress at A and E. So tau A, which is equal to tau E, which is equal to 0. After that, we will calculate at B. So tau B, which is equal to SA y bar divided by IB. So tau B, which is equal to S is 1000 kilonewton. So 1000 into 10 to the power 3 into area. Area is 300 by 50 into y bar. So you observe here, this is 75. Okay. So 75 minus 50 by 2. Then divided by moment of inertia is 130.205 into 10 to the power 6 into width is 300. So tau b, which is equal to 1. Check करा बरं. Check it, check it. Yes. Tau b, which is equal to 19.20 Newton per mm square. After that, we will calculate for C. Tau C, which is equal to same equation SA y bar by IB. Other parameters will be same, only width will be changed. So which is equal to 1000 into 10 raised to 3 into 300 into 50 into y bar is 75 minus 50 by 2 divided by moment of inertia is 130.205 into 10 to the power 6 into width for this C section is 50. 115.20 Newton per mm square. After that, last point is remaining, that is shear stress at neutral axis. So tau B, which is equal to SA y bar by IB, which is equal to 1000 into 10 to the power 3 into, here two strips will be there. The first one is a 300 into 50 into centroid of this is 50, okay, plus 50 into this distance is how much? 75 minus 50, 25. So into 25 into 25 by 2. And then divided by moment of inertia into width. So moment of inertia 130.205 into 10 to the power 6 into width is 50.
One 117.60.
117. Newton per mm square. Newton per mm square. Now stress calculations are over. We have to draw only figure. So we will draw figure. This dimension is 300 mm. This is the 50 mm. This is also 50 mm. And this dimension is 200. Okay. And depth of neutral axis from bottom is 175 and from top this distance is 70. First we will mark points here A, B, C, this is the T, and last one is the E. First we will draw baseline here. Then we will mark points and then draw. So shear stress at A is 0 and shear stress at E is 0. After that, shear stress at B. Shear stress at B is 19.20. Okay, 19.20. 19.20. After that, shear force at C, 115.20, no? After that, shear force at D, 117.60, and shear force at E is 0. So connection is up to this parabolic. After that, straight line, and from this after that. Okay, so this is the shear stress distribution diagram. So this is A point, this is B, C, this is a D, and last one is the E point. Next I section we will solve here, but I will write only question, you solve and give answers. Okay. Those students are attending online, please take screenshots for this example. Over. Shall I take next example?
Yes.
Okay. Please write down next example. A cast iron of I section, a cast iron beam, a cast iron beam cast iron beam of I section as shown in figure below. As shown in figure below. As shown in figure below. It's subjected to a shear force of is subjected to a shear force of subjected to a shear force of 800 kilonewton. 800 kilonewton. Full stop. Draw shear stress distribution diagram. Draw shear stress distribution diagram. Shear stress distribution diagram. Okay, so you solve this question. First you calculate y bar, then I11, Ixx, then stresses. Y bar which is equal to how much? I11 which is equal to how much? Ixx which is equal to, then tau A which is equal to, suppose this is A point, B, C, D, E, F, and G. So tau A which is equal to tau G which is equal to how much? Tau B which is equal to tau C, tau D, tau F, and tau E. I will give 20 minutes. Solve this question. Hmm. which is equal to how much? Y bar.
एकशे 88.46.
ते हो काय तर समेशन ऑफ ए आय किती आलं तुमचं?
32,500.
Okay, 32500. After that, AIYI, summation of AIY
6.124 into 10 raised to 6.
6.42 यायला पाहिजे बरं का? 6.42 into 10 raised to 6. Summation AIYI square
1.605 into 10 raised to 6.
इथं चुकले तुमचं काहीतरी. Summation, sorry, AIYI square for section 1 किती आलेलं आहे?
187.5 into 10 raised to 3.
I am asking AIYI square.
4.675 into 10 raised to 6.
4.687 into 10 raised to 6.
बघू calculator. हा section 1 चा AIYI square
4.687 into 10 raised to 6.
wait 25 square into 4.687 into 10 raised to 6.
6.
हा तेच आहे.
Section 2 चं काय आलेलं आहे?
281.25 into
382.81 into 10 raised to 6.
Wait, I will check. Into 382.81 into 10
हा
raised
मॅडम.
to 6. Okay. आणि for section 3rd
1.302 into 10 raised to 9.
wait, I
हा
will
तेच आहे.
1.320 into 10 raised to 9. Huh? Okay, 32. Then y bar, which is equal to how much? 197.84 mm. Okay. Then you calculate I11, IXX, and accordingly tell me. कसं शक्य आहे 0 मध्ये? 1.11 केतन जरा स्लो सांगा. हा 1 पॉइंट ओके. हा 10 raised to 9. चेक करा बरं हे येते का आन्सर.
Madam, y bar ची व्हॅल्यू 198.061.
198.061 येते का बाय बार? 98. श्रुती एकदा चेक करा तुमचा आन्सर.
मॅडम 198.03 देते वायबर.
Y bar, which is equal to summation AIYI divided by summation AI. Okay, so AIYI summation is how much?
6.436 into 10 raised to 6.
6.4
436.
36 10 raised to
into 10 raised to 6
10 raised to 6 divided by
divided by
sum of area
32500.
32500. तो कॅल्क्युलेटर करा तुमचे कशाने एवढे variation?
198.03 येते.
6.436 into 10 to the power 6 divided by 32500. बघा जर तुम्ही 6.436 पर्यंत घेतलं तर 197.84 येतं आणि 6.436 घेतलं तर तुमचं हे y बारचा आन्सर येत आहे 198.03. ओके मग हे 3 डिजिट घेऊन सॉल्व करा 198.03 ने. हा किती येते केकन IXX 501.4 ओके 501.483. बर तुम्ही y बारची व्हॅल्यू 197 घेतली का 198 घेतली. चेक करा जे स्टुडंट्स ऑनलाईन सॉल्व करतात त्यांनी चेक करा IXX एवढाच येतोय का 198.03 ने आन्सर येते बरं का ते. मग 197 घेतलं तर जास्तच येणार आहे कारण तुमचा जेवढा डिनॉमिनेटर जास्त असणार आहे ते y बार सॉरी मल्टिप्लिकेशन मध्ये व्हॅल्यू जेवढी जास्त असणार आहे तेवढा आन्सर तुमचं जास्त येणार आहे. ठीक आहे ज्यांनी 197 घेतलाय त्यांचा IXX थोडा जास्त येतोय तुमचं. एक लक्षात ठेवा इथून पुढे एक्झाम्पल सॉल्व करताना 3 डिजिट घ्या पॉइंट नंतर 3 डिजिट घेतले ना तर सगळ्यांचा आन्सर सेम येते. तर प्रेफर करा तुम्ही 198.03 ला म्हणजे आन्सर सगळ्यांचे सेम येते.
हा मॅडम सेमच चालेल.
ओके ठीक आहे चला सॉल्व करा. फाइव 501.483 म्हणताय. पॉइंट नंतर 3 डिजिट यूज करा y बार ची व्हॅल्यू 198.03 पुट करा आणि आन्सर कॅल्क्युलेट करा. After that, calculate tau b which is equal to how much, tau c which is equal to how much.
Madam, IXX ची व्हॅल्यू 503 into 10 raised to 6.
किती घेतलं तुम्ही हे 198.03 घेतलंय का?
हा
किती आली तुमची 500
503 into 10 raised to 6.
10 raised to 6. बरं I11 किती आलाय तुमचा 1.776 into 10 raised to 9 येतोय का?
1.773 times 7 into 10 raised to
10 raised to
9.
ठीक आहे मग हा इथं 7 आलाय 6 च्या ऐवजी. हे I11 आलेलं आहे. समेशन ऑफ IXX ला काय आपलं इक्वेशन I11 which is equal to IXX plus summation of AI y bar square. So I11 is 1.777 into 10 raised to 9 minus AIYI summation AIYI is 32 summation of area is 3250 into y bar is 198.03 square. So Ixx, which is equal to hi. काहीतरी समोर होता सगळ्यांचं 500 केलं तुमचं 200 कॅल्क्युलेटर द्या बरं.
Four 98.48 madam into 10^6.
Tau b which is equal to किती येते tau b ची व्हॅल्यू कसं येणार आहे tau b which is equal to shear force किती दिलेला आहे so 800 into 10 raised to 3 please concentrate here tau b which is equal to 800 into 10 raised to 3 after that area is 250 into 50 after that y bar okay so depth of neutral axis from bottom is 198.03 and from top is how much
151.19.
151.97 okay so this is 151.97 minus 50 by 2 divided by moment of inertia Ixx which is equal to 501.48 into 483 into 10 raised to 6 into width is 250 so how much tau b which is equal to किती येते सांगा
10.094.
okay 10.094 that is 10.1 Newton per mm square after that for tau d instead of this for tau c instead of this 250 you use 50 and calculate so 10.094 into 250 which is equal to divided by 50.47 yes so tau c shear stress at c which is equal to 50.47 Newton per mm square after that you have to calculate at d so tau d which is equal to how much Okay, this length is how much? 151.97 minus 50. And then CG is divided by 2. Tau d, which is equal to how much? IXX use करा 501.483 into 10 raised to 6. And we are calculating stress at D. So width is 50 mm. Shear force is 800 into 10 raised to 3 into first strip is that is 250 into 50 into the centroid of this is 151.97 minus 50 by 2 plus then this that is 50 into 151.97 minus 50 which is equal to 101.97. Okay, into 101.97 by 2 and then divided by moment of inertia is 501.483 into 10 raised to power 6 into width is 50. Accordingly, calculate and check tau d which is equal to how much? Yes, tau d which is equal to how much? $58.48. 93. कितने थे? Those students are attending online. Please respond here. Tau d which is equal to how much? 58.93 Newton per mm square. Okay, 58.93 mm square. After that, tau e which is equal to tau e which is equal to. So before e we will calculate tau f. So tau f which is equal to shear force is 800 into 10 raised to 3 into area is 150 into 50 into y bar is 198.03 minus 50 by 2. Then divide by moment of inertia 501.483 into 10 raised to 6 into width is 150. So tau f which is equal to 13.80 Newton per mm square. When you are calculating at E, only depth will be changed. For E, depth is 50 mm. So instead of this 150, use 50. बघा हे 13.80 आलेलं आहे, तर ते डबल कॅल्क्युलेशन करत बसायचं नाही. कसं कॅल्क्युलेट करायचं? 13.80 इंटू 150 करायचं. 13.80 इंटू 150, जे काय आन्सर येईल त्याला डिवायडेड बाय 50 करा, म्हणजे त्याचा आन्सर असेल टाऊ. आता चेक करा ह्या इक्वेशन सेम येते का. सिंपल शॉर्टकट सांगितलं तुम्हाला, ते इक्वेशन यूज करून तेवढं येते का चेक करा. येतंय ना. कॅल्क्युलेशन करायची गरज नाही. इथं लक्षात ठेवायचं काय करायचं, आपण डिवाइड 150 ने केलेलं आहे, तर आलेल्या आन्सरला 150 ने मल्टिप्लाय करायचं आणि आपली जी विड्थ आहे त्यांनी डिवाइड करायचं, त्यामुळे तुम्हाला तिथे आन्सर भेटेल. नाउ स्ट्रेस कॅल्क्युलेशन पार्ट इज ओव्हर, देन वी विल ड्रॉ स्ट्रेस डिस्ट्रीब्यूशन डायग्राम. Okay, first we will draw baseline here. So from this, suppose this is our baseline, I will extend all lines. You try to draw this shear stress distribution diagram. How it will look like. Okay, so shear stress at A is 0. Shear stress at G is 0. After that, we have calculated shear stress at B, and the value of shear stress at B is 10.09. After that, shear stress at C 50.47. Then shear stress at D 58.93. Shear stress at E first. How much? 41.40. And then shear stress at F, which is equal to 13. So suppose here 13.18. So here connection is parabolic, here straight line, here parabolic up to this point. After that, this is straight line and this is parabolic. So this is the stress distribution diagram. Okay. Please remember one thing, whenever you solve examples, you use 3 digits after point. 3 digits. Suppose 10.523, then you use 10.523. So you will get same answer. So this is the stress distribution diagram. Now this shear stress distribution diagram, shear stress says in beam unit is over. We will discuss the MCQ on this unit. We will discuss here MCQs. So I will open MCQ PDF. Please wait. Yes. नाही झालं म्हणून तर MCQ डिस्कस करून आता प्रॉब्लेम जर आले तर तुम्ही सोडवू शकता, पण MCQ आले तर मग तर लय सोपं आहे. Okay, my screen is visible.
Yes, ma'am.
Okay. So here question we will discuss MCQ on bending and shear stresses. So first question is movement of inertia acting on semicircle. Okay, this is not for your syllabus because of only circular rectangular portions sections for you. Then second is what is the movement of inertia acting on a rectangle. So this question is related to your syllabus. Okay. So what is asked? A rectangular section, and the width of rectangular section is 15 mm and the depth of rectangular section is 40 mm. About base by using theorem of parallel axis. That means here you have to find out. So movement of inertia which is equal to 3d cube upon 12. किती आता check करा. 80 into, but this is about neutral axis. तो कुठे असतो? न्यूट्रल ऍक्सिस ला असतो. इथे काय करायला सांगितलेलं आहे? बाय युजिंग पॅरलल ऍक्सिस थेरम, म्हणजे अबाउट बेसला फाइंड आउट करायचं. तर विड्थ किती आहे तुमची? 50, डेप्थ आहे 40, बीडी क्यूब अपॉन 12 अबाउट बेस. So here answer is 320, but how this calculate? कसं काढणार हो बेसला? कसं कॅल्क्युलेट करणार? तर प्रॉब्लेम विचारले तर असे स्मॉल प्रॉब्लेम विचारले जातात. आता न्यूट्रल ऍक्सिसला आपण डायरेक्ट घेतो, एक्स एक्स ऍक्सिसला बीडी क्यूब अपॉन 12, पण बेसला कसं कॅल्क्युलेट करणार? किती येतात? बीडी क्यूब अपॉन बीडी क्यूब बाय 12 इंटू पॅरलल ऍक्सिस म्हणजे बघा, आता आय सेक्शन जर असेल तुमच्याकडं, ठीक आहे. आता आय सेक्शन असल्यानंतर आपण हे 2 मेथड्सनी यूज करू कॅल्क्युलेट करू शकतो. तर फर्स्ट मेथड काय, आपण हे होल कन्सिडर करून फाइंड आउट करू शकतो, आणि सेकंड म्हणजे त्याच्यातून हे 2 पार्ट मायनस करू शकतो. आणि सेकंड मेथड काय की तुम्हाला इंडिव्हिज्युअल कॅल्क्युलेट करायचं आहे, सेक्शन 1, 2 आणि 3, आणि त्या तिघांची ऍडिशन घ्यायची आहे. तर ह्या तिघांची ऍडिशन घेण्यासाठी फॉर्म्युला काय असतो तुमचा? आय एक्स एक्स विच इज इक्वल टू बी डी क्यूब बाय 12 प्लस ए इंटू वाय बार स्क्वेअर, सॉरी ए इंटू वाय बार. तर हा ए इंटू वाय बार म्हणजे काय घ्यायचंय तुम्हाला इथं? तर हा जो काही तुमचा डेप्थ ऑफ न्यूट्रल ऍक्सिस आहे, न्यूट्रल ऍक्सिस पासून सेंट्रॉइड ऑफ दिस, त्या पद्धतीने कॅल्क्युलेट करायचंय. मग पॅरलल ऍक्सिस थेरम म्हणजे काय करायचंय तुम्हाला? हा बेस आहे असं कन्सिडर करायचं, आणि ह्या बेस भोवती फर्स्ट यू हॅव टू कॅल्क्युलेट movement of inertia, and after that you have to convert about neutral axis. हा सांगा काय करायला लागेल? शिकलाय तुम्ही मेकॅनिक्स? काय करायला लागेल? ठीक आहे, डायग्राम खालचं डिस्टन्स काय? आता बीम कितीचा दिलेला आहे आपल्याला? डायमेन्शन किती दिलेलं आहे? 15, विड्थ आणि डेप्थ 40 दिलेली आहे. हा सांगा. कसं कॅल्क्युलेट करणार? 2 स्टुडंट्स आर अटेंडिंग ऑनलाईन, प्लीज रिस्पॉन्ड. काय करायला लागेल? तर आता आपण हे सॉल्व्ह केलं नसतं आणि तुम्हाला एक्झाम मध्ये विचारलं असतं, तुम्ही कसं सोडवलं असतं? काय लॉजिक लावलं असतं? तुम्ही इथे डायरेक्ट काय केलं असतं? 80 × 10⁻³ आणि तुमचा आन्सर चुकला असतं. पण इथं आता काय आहे की तुम्हाला तुमच्या सॉम मध्ये पॅरलल ऍक्सिस थेरम नाहीये. तो थेरम कुठे होता? मेकॅनिक्स मध्ये. म्हणजे सॉमचा टीचर असा अज्युम करून चालतो की तुम्हाला पॅरलल ऍक्सिस थेरम माहिती आहे आणि त्याच्यावरून तो क्वेश्चन डिझाईन केलेला आहे. मग सांगा आता कसं यूज करणार.
IG plus AH square.
IG प्लस AH
Square.
हा कसं कॅल्क्युलेट करणार श्रुती? हा
40 divided by 2 plus 15 into 40 into 14 square.
wait 40 divided by 2 plus 15 into 40 into असंच ना
14 square. हा
40 स्क्वेअर. चेक करा बरं किती आन्सर आहे.
नाही येत मॅडम.
हा काय? हा बीडी हा हा A into H square. Okay. BD cube upon 12 is how much? 80 into 10 raised to 3 plus area is 50 into 40. Then H 20 square. Check the answer. 320 10 to the power 3. बघा लक्षात द्या थोडे इकडे केकननी करेक्ट आन्सर दिलेला आहे. सो पॅरल yes so by using parallel axis theorem you have to calculate first moment of inertia for that particular section and after that AH square. Okay, so area for that particular section into H square. H nothing but centroid of this section, so centroid is 40 by 2. So this equation is related to this parallel axis. That means you have to calculate moment of inertia about base. And if moment of inertia about neutral axis, then your equation is BD cube upon 12. Please remember this thing. If question is about base, at that time moment of inertia is moment of inertia for that particular section plus AH square or AY y bar square. Okay, H square or y bar square means centroid of that particular section. So by using this equation you have to find out moment of inertia. Okay, after that next काय question आहे बघा next. Okay, what is the SI unit of section modulus? Mm raised to 4, mm cube, mm square meter. Please remember here the unit of moment of inertia is mm raised to 4 and here ask for section modulus. So Z is I divided by Y. So mm raised to 4 divided by mm. This mm and mm gets cancelled and what is remaining? Mm cube. Okay, so question will be likewise. After that this numerical we will keep. You try to solve. We will search for theoretical. What is the moment of inertia acting on a circle of diameter 50 mm, pi by 64 d raised to 4. After that, you see here the bending formula is given as. काय असतो bending formula सांगा? M by E, not possible M by E. Okay, M by Y, no. Then M by I, which is equal to sigma by Y, which is equal to E upon R. Okay, so this is option 3 is correct. Then next, which of the following laminas? No, this is not related to your syllabus. Yes, neutral axis of a beam. Neutral axis of a beam always coincides with axis passing through bottom of beam, axis passing through height b by 2 from bottom, axis passing through height h by 3 bottom, axis passing through central. Neutral axis of a beam always coincide with axis. बघा आपला काय असतो neutral axis. Suppose this is our rectangular section, then neutral axis will passes through centroid. So neutral axis will pass through CG. Okay, not h by 2, not h by 3, and through bottom of B. But at neutral, the neutral axis is passes through centroid. Here next is if depth of B is double. Yes, always. If depth of beam, y bar we are calculating for unsymmetric section. No? If depth of a beam is double, then changes in its section modulus. असे पण क्वेश्चन विचारले जाऊ शकतात ना. जर beam ची depth double असेल, if depth of beam is double, then changes in its section modulus. काय चेंज होतील हो? If depth of beam is double, म्हणजे काय होणार आहे तुमचं बीम ची डेप्थ डी च्या ऐवजी 2D होईल. डी च्या ऐवजी 2D होणार. देन वाय मॅक्स किती असणार आहे मग तुमचा 4D कसा असेल 2D आहे म्हटल्यानंतर हा डी असणार आणि हा डी असणार आहे डी. ओके, देन मोमेंट ऑफ इनर्शिया Ixx divided by y max. Then here moment of inertia also change. Okay, and then this y max. So please remember, if depth is double, at that time section modulus increase 4 times. Likewise, question will be asked. Then flitched beam is not in your syllabus, so we will move towards next section. Now, 1 or 2 examples we will see here, then we will stop. In a T section beam, the bending stress distribution will be as shown. कसा असेल bending stress distribution? बघा shear stress distribution shape नुसार change होतंय तुमचं, पण bending stress distribution shape नुसार change होत नाही. तर ते काय असतं तुमचं न्यूट्रल ऍक्सिसच्या अबव आणि बिलो इन्क्लाइन स्ट्रेट लाईन असतं. सो बी ऑप्शन इज करेक्ट. अँड फर्स्ट दिस इज डी इज रिलेटेड टू शियर स्ट्रेस डिस्ट्रीब्यूशन. ओके, आफ्टर दैट नेक्स्ट क्वेश्चन इज आस्क्ड इन अ चॅनल सेक्शन बीम बेंडिंग स्ट्रेस डिस्ट्रीब्यूशन विल बी. चॅनल सेक्शन विचारलंय ना आय सेक्शन दिलंय, क्वेश्चन चुकलंय. The strength of a beam depends on. कशावर डिपेंड असेल बीम ची स्ट्रेंथ? तिथं बघून सांगू नका, तिथं ठीक आहे तिथे दिलंय सेक्शन मॉड्युलस, पण कसं पॉसिबल आहे की सेक्शन मॉड्युलस वर डिपेंड आहे? कशावरून आपण म्हणू शकतो की सेक्शन मॉड्युलस वरतीच डिपेंड आहे? बघा, स्ट्रेंथ मीन्स सिग्मा विच इज इक्वल टू m अपॉन z. सो this sigma is depend on this section modulus. जर सेक्शन मॉड्युलस ची व्हॅल्यू जास्त असेल तर स्ट्रेंथ तुमची कमी असणार आहे. म्हणजे दिस स्ट्रेंथ ऑफ बीम इज डिपेंड ऑन दिस सेक्शन मॉड्युलस. म्हणजे डायरेक्टच फॉर्म्युले विचारतील असं पण नाहीये, तर क्वेश्चन थोडे तुम्हाला लॉजिक लावता येईल असे पण क्वेश्चन इथे विचारले जातात. आपला सिलेबस कव्हर झाल्यानंतर आपण हे MCQ चे एकदा डिस्कशन करूया प्रत्येक युनिट वरचं. ठीक आहे. सो टुडे वी विल स्टॉप हियर. थँक यू फॉर अटेंडिंग लेक्चर. थँक यू.